Hello everyone, I'm Adam. In this problem, for our indefinite integral, we have the quantity x plus 2 squared times sine of x. We're going to find the indefinite integral using integration by parts, but particularly the tabular method. Now before we get to the tabular method, let's take a look at our integral, and we're going to do the same things that we would start by doing if we're going to do integration by parts the long way. Namely, we're going to find first what our u and our dv is. Now taking a look at the type of integral we have, this looks similar to something like the indefinite integral of, say, x squared times sine of x dx. Now, if we had something like this, where we had x squared or some other power cubed or to the fourth times sine of x or cosine of x, right, or e, then generally what we do is u would be our x squared, right, and our dv is our sine of x dx. Now what we have, though, is the quantity x plus 2 squared. Now in fact, we can kind of take this as being the same. So with our quantity x plus 2 squared, we can still let u be that. If we have x plus, say, a constant 2 to a power, say squared, u can be there. And our dv is still going to be sine of x dx. So we have a place to start. So now let's go ahead and kind of set up our tabular method and see what we're going to do with that. So with the tabular method, right, we're going to have our table. So we're going to start it out with 3 columns, one for sine, which we'll get to, one for u, and one for, say, v prime. Okay? Now, sine we'll get to last, but essentially what we're going to do is for our u, we're going to start with what we let our u be equal to, which was the quantity x plus 2 squared. And the process here, for what we let u be equal to, we're going to take successive derivatives until we get to 0. And then also our v prime, which what is that? Well, if we look at our dv, right, symbolically, this is equal to v prime dx. So our v prime is just going to be kind of the function part without the dx, or our sine of x here. So we're going to start there. So we're going to take derivatives with our u till we get to 0, and then looking at our v prime, we're going to take our antiderivatives all the way down till we get to the place where we were at with 0 with our u column. So let's start with u and go down there. So we'll take our derivatives. So derivative of x plus 2 quantity squared is going to be 2 times the quantity x plus 2, and the derivative of that is just going to leave us with the constant 2, and the derivative of 2, right, is 0. So now we have a stopping point when we come over here to our v prime column. So now we're going to take the antiderivative. So the antiderivative of sine of x is minus cosine of x. Antiderivative of minus cosine of x would be minus sine of x, and the antiderivative of minus sine of x would bring us to, say, a positive cosine of x. Now to complete our table, let's look at the sine column. So what we do here is taking the signs, we always start with a positive, and then we alternate our signs all the way down to wherever we hit 0 at the bottom here. So we start with positive, then be negative, then positive, and lastly negative. Now we have our table filled out, and we'll see how we're going to use that. So our indefinite integral of the quantity x plus 2 quantity squared times sine of x dx, right, is going to be equal to, looking at our table now, so what we do is start at the top row and with our signs, and we think of kind of going across and down. You can even think of multiplying if you want. So I'm going to multiply the first term with, say, a positive 1, and then multiply that term going down my diagonal. So we're going to have a positive x plus 2 squared times negative cosine of x, which will give us a first term, say negative x plus 2 squared times cosine of x. And we just repeat the process till we get down to the bottom. So the next row, I'm going to come across and down. So think of multiplying by a negative 1. So we have negative 2 times x plus 2 times negative sine of x, which will give us plus 2 times x plus 2 times sine of x. And across the next row, coming across and down, so a positive 2 times cosine of x. So plus 2 cosine of x. And we even think of going across on the very last row, but we don't have anything other than just 0. So then the last thing that we're going to have with our antiderivative here is, of course, our constant of integration, so plus some constant c. So the antiderivative of our quantity x plus 2 squared times sine of x, right, is equal to negative x plus 2 squared times cosine of x plus 2 times x plus 2 times sine of x and plus 2 cosine of x plus c. So there we go. Thank you very much.